I welcome you to the next part of this module. The one system which is very important and critical in a hospital is the HVAC system. HVAC stands for heating, ventilating and air conditioning. HVAC systems generally include the following basic components: a heat generating system, a cooling system, an air handling and filtration system, and a control system for operations. The HVAC system is meant to provide complete conditioning of the air, which may include the filtering out of dust and odors, freshening with outside air, adjustments of the temperature, and adjustment of the relative humidity. The temperature can be modified anywhere in the building with the help of the BMS and also manually by the thermostats which are placed everywhere. Some factors that must be taken into account for HVAC systems are the space for equipment, the noise and vibration of the equipment, space for air duct systems, and the properties of the building enclosure. Proper space must be allocated for all this. HVAC equipment is generally very large and bulky. To be operationally feasible, the equipment must also be strategically located. The equipment must be accessible for maintenance and replacement purposes. Noise and vibration are other factors that must be considered during the design stage. This is critical for cooling equipment and large fans. HVAC systems require large spaces for air duct networks too. Ducts are used to serve the building interior spaces and link up with the operating equipment. The air intake and exhaust must connect to the outdoor air at appropriate locations. As discussed before, compartmentation is a very important aspect in hospitals. The HVAC system is a very critical service in a hospital. Its complication comes from the fact that a hospital is filled with people with infections. The HVAC system has to be so designed so that there is no cross-contamination from one to another, and it has to be avoided at all costs. We cannot afford to have cross-contamination through the HVAC system. This is done generally by creating compartmentation and use of filters and scrubbers. Compartmentation is done by many ways. First is physical separation. Then we can use water curtains, air curtains, and we also use a pressure difference to create that compartmentation. Each department in a hospital will have its own individual AHU, and this air is not mixed with any other air. Additionally, all critical areas also have their own individual electrical flow panels and their individual UPS. For HVAC in a hospital, chilled water system is perhaps the most efficient system, even though its initial cost may be high. As we can see in this image, the chilled water pipes from the chiller, they go to all the AHUs where heat exchange takes place and the air is conditioned. This conditioned air is supplied to the building via ducts. After the heat exchange, the water is sent up to the cooling towers for pre-cooling and then back to the chillers for final cooling. The various equipments that are used in the HVAC system are, first of all, a chiller. In a large hospital, we need high efficiency chillers. A chiller is a machine that removes heat from a liquid via a vapor compression or absorption refrigeration cycle. This liquid can then be circulated through a heat exchanger to cool air, which is then circulated through ducts throughout the hospital. The HVAC plant room is generally placed in the basement. Now there are the air handling units called the AHU. AHU is a device used to regulate and circulate the air as part of the HVAC system. An AHU is usually a large metal box containing a blower, heating and cooling elements, filter racks or chambers. It is very noisy and needs dampers and acoustic lining. As we can see in the attached diagram, AHUs supply conditioned air to every area of the hospital through ducts. Another set of ducts take return air from every area and return it to the AHU. This air is conditioned again and supplied. However, a small amount of fresh air or treated fresh air is mixed in it. Now, how much fresh air is to be induced or how many air changes per hour is different from regular buildings, and in hospitals it is designed as per ASHRAE 170. The air changes per hour is different for each type of area within a hospital also. An AHU should have access to fresh air either through an external wall or through an adjoining shaft. In a hospital, return air and fresh air needs to be filtered before conditioning and before supply. This is done by different types of filters placed mostly in the AHUs. AHUs may be placed on the service floors. Additionally, there may be some floors or ceiling mounted AHUs on every floor according to the area they are serving. In a hospital, all critical areas have an AHU of their own, so as not to mix the air with other areas. The next component of HVAC is cooling towers. Cooling towers use the evaporation of water to remove process heat and cool the working fluid from the return air. This slightly cooled water is then sent to the chiller to be thoroughly cooled. Cooling towers have to be placed in the open. The terrace is a commonly used location for cooling towers, even though they can also be placed outside in the setbacks, etc. A thermal wheel is an instrument through which a large percentage of heat can be recovered using ventilation and transferring it to incoming fresh air. Next we have is the fan coil units. A fan coil unit, also known as FCU, is a simple device consisting of a heating or cooling heat exchanger or coil and fan, as you can see in the picture. Ducts are used throughout the hospital. Now ducts are metallic tube-like elements which carry conditioned air and return air through an HVAC system. The cross section is designed to optimize the airflow. The duct sections vary through the network with varying amounts of air through them and its pressure. They may need thermal and acoustic insulation as well. So ducts, in this image that you see, you will see that ducts have not only varying diameters, but they also have special jointing so that air may not leak from there. Diffusers and grills are installed at the supply end of the duct to diffuse and supply the conditioned air. Many types of filters are used to clean air in a hospital. Air to and from different area needs to be filtered with different levels of filtration depending on the level of contamination or the cleanliness of the air which is there. There are also high efficiency particulate air filters, more commonly known as HEPA filters, and this is an efficiency standard of air filters. Filters meeting the HEPA standard mostly satisfy certain levels of efficiency. Filters may also be MERV rated. Even though in many large commercial buildings in the warm regions of India, we do not provide winter heating. But in hospitals, maintaining optimum temperatures is important and heating and cooling are both provided. So for heating, we use boilers. Boilers produce steam which gets pumped throughout the hospital and is responsible for keeping a comfortable temperature as well as for maintaining the right level of humidity so as to prevent the growth of viruses, bacteria and fungus. HVAC systems have their own independent boilers and not linked to the normal pumping system. In summers, chiller water is provided by the chillers, and in winters, boilers are used to run hot water through the pipes. For this, we can use either a 2-pipe system or a 4-pipe system. The 4-pipe system has a higher initial cost as it uses more material but achieves better results. In this, 2 pipes are used for hot supply and return of chilled water, and the other 2 are used for the supply and return of hot water. For a small hospital, for the purpose of cutting costs, 2-pipe system can be used, where the same 2 pipes are used for supply and return of chilled water in summertime and for hot water in the winters. In that case, we still have to provide a 4-pipe system for critical areas like the OTs and the critical care units. Ventilation is also a part of HVAC. So for ventilation of the non-air conditioned areas like the basement, we provide a ventilation system using a network of ducts and fans, or we can use jet fans. These are especially critical for smoke extraction during a fire, and a correctly system design is important, which is as per the codes, and it is mandatory before the fire department will give you a no objection certificate for that building. Ventilation can be done in 2 ways. The first is ducted. In a ducted system of ventilation, on one side of the building, we install shafts and fans for supply of fresh air through the ducts. On the other side, we provide shafts and fan rooms for return air through the ducts, as can be seen in the image. Both the supply and return ducts are spread throughout the area to be ventilated, sort of like this. In the example seen in the drawing, The supply ducts are being taken at the ceiling level throughout the basement. The supply ducts are then taken down along the columns and the supply of fresh air is at a lower level. Return air is taken from a higher level. The second method is jet fans. A jet fan system is a duct-free system relying on a series of strategically placed jet fans to control and distribute air around the basement area. Main extract fans take the contaminated air out of the car park with fresh makeup air supplied from the entrance or exit ramps or through supply fans required. A CFD, which is a computational fluid dynamics simulation, is recommended to be very sure that the system is correctly designed to extract all smoke during a fire. As basements may be used for car parking, sensors are installed to monitor carbon monoxide levels. HVAC plant room. The HVAC plant room is located in the basement and requires a double height due to the size of equipment and its operations. It houses the chillers and the various pumps for HVAC. It also houses boilers for winter heating and humidity control. HVAC plant room of a large hospital is a major source of electrical consumption and it may even consume up to 60% of the total electrical load. Therefore, it is advisable to provide a dedicated HVAC electrical panel and it is preferable for the HVAC plant room and the electrical rooms to be as near as possible. Now, in a hospital, we have many special types of areas and we will discuss them one by one. The first very important area is emergency. Emergency has to be the most easily accessible area for someone coming from outside. It should have some space for parking of ambulances and visitor vehicles. Emergency is provided with a separate flow mounted AHU with a pre-filter and fine filter, and the air is also treated with UV light. As with all critical departments, we provide an individual electrical panel and UPS. It is provided with hot and cold water supply also. Now we come to the operation theatres. For the operation theatres in the hospital, there would be special requirements of drainage. A separate ETP drainage line is provided for the operation theatres. If the OT is in the basement, it would have its own sump and pumps also, one pump working and one standby. One dedicated autoclave unit is provided for the disinfection of laundry from the OTs only. Each OT has a dedicated UPS which is connected to a centralized UPS. Operation theatres are usually planned as a set of OTs near each other. There may be 2 to 10 OTs in a set. OTs have 3 levels of barriers. As you can see in the sketch below, the dirty corridor, then they come the services, then the clean corridor, and then the operation theatres. The operation theatre doors are hermetically sealed to prevent anything from entering. Every surface in the OT is washable and there are no sharp edges in the civil work and they have to be rounded off for the purpose of cleaning. Each OT has a dedicated AHU fitted with pre-filter and fine filters, humidifiers, smoke extraction fan and UV chamber. A good HVAC solution can be to provide a laminar flow plenum in the OT fitted with a HEPA filter in the center of the OT suspended from the ceiling slab above the false ceiling to give in the conditioned air. The return air may be collected from all the 4 corners, raised 450 mm above the floor. The next area to be discussed is the critical care and intensive care units. The most critical areas in a hospital are OTs and the critical care units like the ICU, ICCU, PICU, NICU, etc. One AHU fitted with pre-filter and fine filter and designed for smoke ventilation is provided for each unit. Each CCU has an isolation room. The HVAC system for the isolation rooms is to be so designed that conditioned air is only supplied there and no return is taken from there. Air is fully exhausted out, preferably at terrace level. For reasons of public health and hygiene, the air should be exhausted after passing through a HEPA filter. As all other critical areas, each CCU is to have its individual UPS which is connected to the main UPS. Contamination is a major concern in all critical areas. We use the technique of differential air pressure. In all such areas, we keep the pressure higher than the surrounding areas and corridors so that no air and therefore no infections come into them through the door openings, etc. Fire safety of patients on life support is quite critical and it has been discussed in the fire safety section. Smoke extraction and exhaust system in HVAC. Where critical patients are there, the air is treated with UV rays in the AHU for purification. In the hospitals, you also have LINAC rooms, which are linear accelerator rooms. Now, the linear accelerator rooms may be there in the basement. This is a part of oncology, where external beam radiation treatment is given to cancer patients. Obviously, this is an extremely sensitive zone and it needs to be made radiation proof. And that is done by using thick RCC walls, maybe around 1100 to 1200 mm thick. Sort of like in a nuclear bunker. LINAC room will have its own separate ETP line for discharge of effluent along with its sump and pump. Now in this drawing we can see that at places the LINAC room's walls even extend up to 2400 mm thick. The next department that we discuss is radiology. The radiology department is most often located on the ground floor for sake of easy access. It's a critical area as it houses very heavy and very sensitive equipment. Equipment for testing like X-rays, MRI scans, CT scans, ultrasound, etc. It has a separate floor mounted AHU as the area is quite big, which is fitted with filters like pre-filter and fine filter. The air has particulate matter, pollutants, chemicals, bacteria, germs. The radiology equipment is extremely sensitive and needs to be protected. So we ensure that nothing enters from outside directly. The radiology department is also a major consumer of electricity. So we provide for a separate electrical floor panel for it and its own UPS. The MRI or the magnetic resonance imaging scan is based on magnetic resonance and the room has a magnetic field. We have to avoid metal ducting and all other metal parts. The MRI equipment specifications will specify the minimum distance at which the metal ducts can be placed. In this room, smoke ventilation and extraction is not really required in the HVAC. Now we come to the outpatient departments or OPDs. As soon as we enter the hospital, there would be an atrium area or a large entrance lobby, and quite nearby we will have the outpatient departments. These areas have a large number of people visiting and waiting and are critical due to the high population. It's important to have a proper system of smoke extraction and fresh air supply in these areas. In small hospitals, it is possible to have a ductless systems of ventilation, but in case of large areas or high occupancy, it is important to have a ducted system of smoke extraction and for the windows to open automatically so that fresh air may enter as smoke is being exhausted. OPDs are often placed on the ground floor, but depending on the numbers can be distributed on any other floor too. Consultation room, if they are large for OPDs, can be air conditioned with individual FCUs suspended from the ceiling. If the number of rooms in one area is quite large, it is more efficient to use one floor mounted AHU for all of them and then provide conditioned air through individual VAVs, which are variable air valves. Some outpatient consultation rooms have particular requirements also, which have to be serviced. For example, a dental consultation room will require water supply and drainage. A cardiac consultant will require specific requirements for electrical power. Now we come to individual rooms and wards. For the inpatients, there are rooms and wards. Rooms may be single or double occupancy. Rooms with the 4 patients or more are treated as wards for the purpose of services design. In individual rooms, conditioned air may be supplied through fan coil units or FCUs suspended for the ceiling. In the corridor just outside the room, the supply grill is in the room and the return air is taken from just under the FCU in the corridor. The wards are provided with a small ceiling suspended AHU in a corner for the ease of maintenance. Air distribution through the ward is done through diffusers. Each room will have a thermostat for temperature control as per the individual requirement. One possible layout is shown in the drawing where we see the location of the FCU in the corridor outside the room next to the toilet. Room toilets are generally located near the entry for ease of maintenance and hygiene. This brings us to the end of this part of this module. Thank you. Namaskar.